Hi, and welcome to Chapter 23, Learning Objective 4. What we're doing in this particular learning objective is we're going to learn about nominal and real GDP. We're going to take nominal GDP and learn actually how to convert it to real. And then we're going to study the leftover portion, which is inflation, a general rise in the price level. One measure of inflation is the gross domestic product, GDP deflator. So we're going to learn how to do that as well. So let's go ahead and jump into it, and I'll share my screen with you. Okay. So the first thing that we want to look at here, come on, there we go, is to distinguish between nominal and real GDP. So if you think about it, the formula for nominal GDP is it's equal to real GDP plus inflation. Okay, think of it like a pie, if you will. So we have a pie that is nominal GDP. Some of that pie is consisting of actual growth in goods and services. That would be the real portion. We would then have a remainder, which would be inflation. What we're going to learn to do in this lesson is we're going to parse out the real, and we're going to take a look at that in terms of real growth. And this would be growth that is actually an increase in output for the economy. And so this would be good growth, okay? Then what we're going to do is to look at the remainder of this and to make some judgments about how prices have changed. Okay, that's going to be the inflationary point. Inflation is a general rise in the price level over time. There can be deflation, which is a general lowering in the price level over time. So we're going to look at this. Two effects of inflation. The first effect is that the prices go up of goods that we buy. The second effect of inflation is that your dollar does not buy as much. So the worth of a dollar, if we have inflation, will decrease. So essentially, it takes you more dollars, physical dollars, maybe that's a good way to say it, to buy the same amount. This is where people will have a higher demand for currency, or dollars in this case. Okay, so we're also going to take a look at, again, the real. We're going to look at some historical GDP. We'll define this deflator, which is the inflationary component. We'll figure out how to calculate that. And lastly, we'll take a look at pricing and consumption for real GDP. Okay, the easiest way to explain this is to use an example. Okay, now again, remember that GDP is expressed in nominal, so it's got inflation in it, and we want to figure out how to take nominal and to convert it into real. So that's our first real objective. So we want to correct it for inflation, okay? The other portion is to kind of give you a perspective of why people might give you economic data in nominal terms, because it makes things look better than what it is. Okay. All right. So let's go ahead and jump into this. If you're interested, you can click on this link, which gives you a nice little primer to the difference between nominal and real. Okay. And it's done by the Federal Reserve Economic Database, Dr. Walla. So here's our example. Let's say that we have an economy that produces only two goods. Again, textbook land, pretty simple. So we have good one, which is pizza, and we have good two, which is lattes. Okay. We have 2005, 6, and 7. At this point, everything is expressed in nominal, but let's show you how to calculate nominal. So we're going to compute nominal in each year because that's the first thing that you always want to do. Essentially, we're going to take the price of pizzas times the quantity. We're going to add that to the price of lattes times the quantity. If we had other goods, we would continue to do that. And then we're going to sum them up for each year that we're given. Okay, so let me just erase that so I've got some room to write in here because I want to actually show you how we calculate this. Let's see, there we go. Okay, so for 2005, price times quantity. So 10 times 400 is 4,000. 2 times 1,000 is 2,000. Add the 4,000 with the 2,000 and we end up with 6,000. That's our nominal GDP for 2005. I like to say stay in the lane because you don't want to jump from year to year. So stay on the rows. Okay, that's important at this step. Now we're going to calculate nominal for 2006. Again, doing the same thing. Price times quantity, 11 times 500 is 5,500. 250 times 11, I don't know off the top of my head, so let me grab my calculator. It's hard getting old because you have to look over your glasses all the time, but that's okay. How about 2,750? We're going to add that to the 5,500, and it gives us 8,250. Again, this is nominal. It includes inflation. We're going to take our 12 times our 600, which I believe is 7,200, and our 3 times our 12, which is 3,600, and 72 plus 36. How about 10,800? Okay, so this is nominal, and it has inflation in it. Because you're learning the right way to evaluate economic information, one thing you would never want to do at this point is to calculate growth. The reason is we don't know how much of this growth is actual output of pizzas, actual output of lattes, or was it result from changes in the price? Because we're interested in economic growth, real output of goods and services at this point. Okay, so you're not going to do this, but let's say that you didn't know any different. So you have the numbers, and you're going to say, hey, look at how great the economy's doing. We increased pizzas and lattes 37.5%. We increased pizzas and lattes 30.9% from 2006 to 2007. This is incorrect, okay? Because how much is attributable to actual growth and how much is attributable to changes in price? We just don't know at this point. So what we're going to do is we're going to take this nominal data and turn it into real data. So how do we do that? The first thing we want to do is to choose a base year. Now, the base year is going to be different depending on the data set that you're using. In very large data sets, we use certain years like 1984, 2006, I believe. And so you don't have large data sets. You live in textbook land in this course. So for us, unless you're told otherwise, read carefully on these. The first year you're given is always going to be your base year. So we're going to use 2005 as our base year. Because we're using 2005 as our base year, when we get to the interpretations, we have to be careful because we have to include 2005 data. And I'll explain that a little bit more when we get there. So essentially what we're doing at this point is we're going to hold the price constant in the base, but allow the quantity to change. But that will strip out the price effect, the inflationary component. So we're going to do the same thing, but we're going to hold the price constant in the base and multiply it by the quantity. price constant in the base, multiply it by the quantity, and then sum those up. That's essentially what we're doing to get to real. So let's see how it's different. 10 times 400 is still 4,000. 2 times 1,000 is still 2,000. Add those two together, we get 6,000. Now, why is it the same? Because it's the base year. So the base year, the nominal and real will be the same number. Where we get a little bit different, I'm going to change colors here so you can clearly see what we're doing, is now in 2006, we're going to take the price in 2005, multiply it by the quantity in 2006. So 10 times 500, 5,000. So that's different. 2 times 1,100, 2,200. Add those two together and we get 7,200. 2007, we're going to take 10 times the 600, which gives us 6,000. The 2 times the 1,200, which gives us 2,400. And add those two together, we get 8,400. Very different than what we had before. Now, if you wanted to calculate growth, you could simply use the percent change method in mathematics, delta being change. So how do we calculate that? We take the most recent or the newest time period minus the previous. Do that first, divided by the previous, times 100, and then express it as a percent. So now we have our answers, right? And where did this 20% come from? The 20% came from 7,200, the most recent year, minus 6,000. Do that first, divided by the 6,000, times 100, and we'd end up with 0.20, which is actually 0.20 from the first portion. It would be 20, and we express it as a percent, 20%. Where did the 16.7 come from? Again, 8,400 minus 7,200 divided by 7,200 times 100. That's where the 16.7. Now, one thing that's important to note here is now we're looking only at that portion. I'm going to get rid of that because I want to do, oops, sorry about that. I want to do some additional writing over here. Sometimes it doesn't like it if I erase, so. Okay, good. All right, so in looking at this, I wanted you to see the difference. So the difference is when we used nominal, and I made a notation, it was 37.5% growth. A lot different, isn't it? 30.9% growth. So why would someone tell you nominal? If we all know to use real data, why would someone do that? Well, if you're running for election or re-election, which one looks better? You might say, hey, look how great I did, and use nominal. Are you lying? No, you're omitting some stuff. How many people, though, know this stuff? Not many. If you are running against someone, you might say, au contraire, you only grew the economy 20%. Now, is 20% and 37.5% good growth? Well, here's where I want to interject real life, because what we do know is that GDP in the real world grows at about 3%. That's considered good. Above that is considered really good. But what I get fascinated at many times is especially people running for election or re-election, and they start to say, we're going to grow this economy at double digits. If 3% is good, we haven't seen 10 in a very long time. And so I show this to you so that you can become a good consumer of the information that you're given. So let me go ahead and jump back into this. Okay, essentially what we've done so far is we have looked at that pie piece, right? That pie piece, and now we know what part is real. In the next portion, what essentially we're going to do is to examine that slice of the pie that's inflationary. So let's go ahead and do that. So again, this just kind of illustrates the differences between nominal and real GDP. Okay, so let's look at this inflationary piece. Now, inflationary piece, again, a rise in the price level. So we're going to be examining just this piece right here, which is inflation. And as long as we know nominal and we know real GDP, getting to the inflationary piece is pretty simple because what's left over, right? Because we know that nominal is equal to real plus inflation. So how we do this is we're going to take these numbers, nominal and real, and to take a look at what would happen or what happens in inflation. Okay, now I just wanted to show you we have the gross domestic product here, nominal, right? The red line is nominal. The blue line is going to be real. This is from the Federal Reserve Economic Database. This is actual dollars and billions. It's not percentage change, but again, it grows at about 3% change. So when we look at this, there have been many periods where the real has been greater than the nominal because we didn't really have a lot of inflation. And then they intersect, and now we have some inflation coming in. This is from, again, the Federal Reserve Economic Database. If you want the live data, you can just click on the link and it'll take you right to the live data. Okay. Oh, it doesn't like it. I got to erase my ink. Okay, there we go. All right, so now we're going to examine this slice called inflation. To do that, we need our nominal and our real. Okay, so here's our nominal and here's our real. The first step of this is we want to calculate the change in prices. So remember, when we have inflation, prices are going to go up. The value of $1 is going to go down. Okay. Now, again, in real life, we use lots of data sets. So it's really easy to look at this using what we call basis points. Basis points are 1/100th of a percent. Okay. So we're going to first calculate our basis points and then calculate the inflation rate. How do we get to the GDP deflator, which again is just that pie piece, which is the inflation? The first thing that we want to do is to take our nominal GDP and divide it by our real GDP and multiply it by 100. So when we do that, 6,000 divided by 6,000 is 1 times 100. The GDP deflator is 100. The GDP deflator in the base is always 100 because that's how we are expressing these. So any statements that we make or interpretations have to include this idea of what is $1 worth in 2005. Because $1 is worth a $2005 here and the GDP deflator is 100, then we know that what is the price of things and then what's the value of $1 in 2000, a $2005. So if you go down to the dollar store in 2005, it's going to cost you $1. And the value of your dollar in 2005 is $1. Hopefully that's pretty simple to see. Do not express the GDP deflator as a percentage. It is not a percentage. It is basis points. I do take test points off for the test. So not a percent, okay? You have to do one other thing to get to that. Okay, So let's go ahead and continue our GDP deflator exercise. So we have 8250 divided by 7200 times 100. And I'm going to grab my calculator, and that ends up being, let's see, 8250 divided by 7200. How about 1 times 100 would be 114.58. Okay, so in 2006, if you walked into a dollar store using a $2005, you would actually need $1.14. Prices have increased by 14 cents. Okay, so you would have to use additional $2005 to go to the dollar store in 2006. It would cost you more than $1 because prices have risen by 14 cents. Or to put another way, you can take the reciprocal of that and say, what's $1 worth? And we would subtract $1 from 14 cents. And we would say that the value of a $2005 in 2006 is going to be 86 cents. So it takes you more dollars to buy the same amount of goods and services. Let's go ahead and do it for 2007. 10,800 divided by 8,400 times 100. And that's going to give us 10,800 divided by 8,400. How about 128.57? Okay, this means that if you go to the dollar store in 2007 and you spend $2005, you're going to have to, prices have risen by 28 cents. So what's a $2005 worth in 2007? Well, we're going to take the reciprocal, so $1 minus 0.28 or 28 cents. That's certainly not right. Minus 0.28, how about 72? Yeah. So now the value of a $2005 in 2007 is 72 cents. So you can see that the value of the dollar is going down, prices are going up, and we're going to study that a lot more in upcoming chapters. Now, notice I kept talking about a $2005. Now, the other reason we like basis points, so I'm going to kind of, let's see, I want to do this. Okay, I'm going to stick with this column right here this column right here, just the GDP deflator, and show you why economists like to use the GDP deflator. Okay, the reason we like it is because I can quickly make statements. So I can say in prices rose 14.58%. Notice where I took that from. I took it from the GDP deflator, right? I lopped off the 1, and that's what gave me the 14.58. So prices rose 14.8%. Now, this is the important part, from 2005 to 2006. Likewise, I can also say, this is where the interpretation has to include the base, that prices rose, and again, 28.57% from, and again, I have to start with the base, 2005 to 2007. Notice that all my interpretations have to include the base. So it is okay to use the GDP deflator to go from 5 to 6 and from 5 to 7. What you can't do, and don't do, please, please, please don't do this. You can't go from 6 to 7 and say the difference between these is about 14, so therefore prices rose 14% between 6 and 7, because they didn't. We have to do an additional step for that. So the additional step that we would use is very similar to the percentage change, right? Percent change. So now we need to, if we want to go between years, you have to go and use this formula of the most recent minus the previous divided by the previous. Again, doing that first, times 100 and expressing it as a percent. Because it looks like the answer should be 14%. But guess what? When we grind this formula out, and let me do that, 128.57 minus 114.58 divided by 114.58 times 100%. How about 12%? 12.21%. So notice that it's not 14. You can't do that. So don't do that, okay? A lot of students want to do that. All right, so again, here's our GDP deflator. Again, the deflator is not a percentage. We can use this to go from here to here or here to here. Just simply lop off the 1. Notice too, it makes sense. Did prices go up? Yeah, they did, right? So the number that you get as a GDP deflator has to be greater than 100. If prices were to have fallen here, then this would be less than 100 and you would have deflation. Okay, here it's greater than 100, so we have inflation. Okay. All right, so here I want you, I have a different setup to the table because you'll see different things in different ways. Stop the slides here, and I would like you to compute the following information. Nominal GDP in 2007, real GDP in 2008, and the deflator in 2009. Go ahead and start for the answers. Okay, so let's go ahead and do this. So let's start with nominal GDP in 2007. So essentially what we're going to do is do the price times quantity plus price times quantity. We have good A, we have good B, and we're looking at 2007. So I'm going to do price times quantity. That's going to be 2,700. Price times quantity, and that's going to be 19,200. I'm going to add those two together. Plus 2.2, about 21,900. So GDP nominal 21,900 for 2017. Okay. All right. Let me move on to the second one. Let's compute real GDP in 2008. Remember, in real GDP, we're going to hold the price constant in the base and allow quantity to change. So I'm going to take 30 times 1,000, which is 30,000. 100 times 200, which is 20,000. And I end up with 50,000. Most students, once they see it, they go, oh, okay, I get it. All right. Okay. Now, let me go ahead and erase that. Now we want to compute the GDP deflator for 2009. This is usually where students get stuck, right there. Like, now what do I do? Well, remember, the first thing you have to do in computing the GDP deflator is you have to take the nominal GDP divided by the real GDP times 100. So we have to come over here in 2009 and kind of start over. Price times quantity, price times quantity. So we get, let's see, 36 times 1050. How about 37? 37,800. 20,500 plus about 58. Our nominal is 58,300, and that's our nominal. Okay. Now what do we need to do? we need to figure real. So let me just grab a different color here. Holding the prices constant in the base. So now we have 30 times 1050. All right. And that would be 31,500. 100 times 205, which is 20,500. How about 52,000? So our real is 52,000. We're going to divide our nominal by the real, multiply it by 100. So we have 58,300 divided by 52,000 ends up being times 100, ends up being 112.12 basis points. Don't put it as a percentage. So what is the 112? How can we interpret that? So let's do the interpretation of this because I really want to make sure that you understand it. So this 112 says that between, now remember dates matter, 2007 and 2009, prices increased, because it's greater than 100, 12.12%. Or a dollar in 2007, a 2007 dollar is worth how much? You're right, 88 cents. And so therefore you go down to the dollar store, things are actually going to cost you $1.12. Hopefully that makes sense. If not, or you want to see additional problems, please let me know. So this just runs through and makes sure that I got the right numbers. Looks like I did. Good. Okay, that's the end of this learning objective. And so again, if you'd like to see some practice problems or anything like that, please let me know. There are some additional problems in the slideshow or in the supplemental exercises. Thank you. Have a great day.